Okay, I think we'll start. Thank you all for coming. This is a very special occasion every year when we get together and remember the lifelong contributions of Jim Steele. And I'd like to just say a few words about him, and then Dr. Ball will introduce this year's James Steele lecturer. Dr. Steele, after his training at Michigan State and Harvard during World War II, was commissioned into the Public Health Service as Chief Veterinary Officer. And in 1946, teamed up with Joe Mountain to develop the CDC. It was then called the Communicable Disease Center in Atlanta. Later, he was the first veterinarian appointed Assistant Surgeon General in the U.S. government. In 1951, he teamed up with Alexander Langmuir at the CDC to establish the Epidemic Intelligence Service, which has become the elite medical public health SWAT team involved in investigating epidemics around the world. In 1971, at 58 years of age, Jim left the CDC, retired from the CDC, came to Houston, and was appointed Professor of Environmental Health and Sciences at the new University of Texas School of Public Health. And he and his wife, Brigitta, moved to Houston from Atlanta. In looking at Dr. Steele's incredible contributions to public health, I put them in four categories. First, he worked with health agencies, federal, national, state, to establish principles by which diseases transmitted from animals to humans were reduced. Brucellosis, bovine tuberculosis, echinococosis, Rift Valley fever. There were a lot of diseases that Jim Steele truly eradicated and helped to eradicate as public health problems. Second, Dr. Steele created the field of veterinary public health. And this important field of public health, if you look at all the leaders in this country, they were either trained by Dr. Steele or trained by Dr. Steele's trainees. So he created this field. Third, he, with his colleagues, established the field of zoonoses, of diseases transmitted from animals to people. If you look at all of the infectious agents that affect human beings, 75% of them come from animals and are considered zoonotic disorders. 16 of the last 18 emerging infectious diseases came from animals, and animal control was essential to human control of disease. And that leads to Jim Steele's final contribution, and that is working with his trainees to establish the concept of One Health. You can't have human health without animal health, without environmental health. And this triangle Jim talked about as One Health. The Jim Steele lecture was inaugurated in 1993. It was organized by then Dean Palmer Beasley and me, and was established when Jim was a mere 80 years of age. And Jim sat in the back throughout the next 21 of these with his booming voice saying very cogent things about the lectures. This is an important way, this lecture, is to remind public health faculty and students here in Houston of the legacy of one-of-a-kind scientist, one-of-a-kind public health leader, and friend to many of us. Dr. Ball, you have the next job. Thank you.
Okay. So I have the pleasure of introducing our James H. Steele lecturer for this year. Our lecturer is Ann Reid. She's a very interesting person and had a very, I think she would say, a non-traditional route through academia and science to lead her to the position that she's in now. So very briefly, at the age of 15, she started her bachelor's and studied environmental science, and then later did a master's in European studies. She moved into policy, and after several years, took a position in a laboratory, and that was really where I think she's explained to me that she found this love for science. And she worked with the Walter Reed Army Medical Center, and later the Armed Forces Institute of Pathology, where the work that I'm most familiar with that she's done is the sequencing of the 1918 influenza pandemic virus from preserved samples. And this work was very influential in my field, and certainly in trying to understand where pandemic viruses emerge. She later moved to the National Academy of Sciences and worked in policy and to the American Society of Microbiology in 2010 to 2014. In 2014, she took over the role of at the National Center for Science Education, where she's defending the integrity of science education. And I think as public health educators and public health students, the topics are very relevant to all of us. So I think we're all very excited to hear your talk, and I'd like to welcome our speaker. Ann, please. Thank you.
What? Okay, can you hear me? Fantastic. Okay, thank you so much for inviting me. It is really an honor to be the James Steele Annual Lecturer. As Justin said, I worked in the field of influenza for many years, and it's perhaps the poster child for One Health. That it's a virus that infects a number of different species and jumps back and forth between them. It makes it a massive public health challenge. And we know that at least once it caused a pandemic that was severe enough to kill somewhere between 20 and 40, some people say as many as 50 million people. So it's important. And so this idea of One Health is something that has been meaningful to me for a long time. So it's a particular honor to be chosen to be the lecturer. But today I'm going to talk about a different ecosystem. While it's true that humans and animals, and I got to throw in the microbes because they're super important, and most of them are good, that is one big system, and we need to think about it systematically. But there's another system that I want to talk about, and that's the scientific enterprise. It's international. I'm going to talk about the U.S. part of it today. But science doesn't happen in a vacuum. Science happens in a society. And scientists don't emerge fully formed. Scientists come up through the education system. And so good science education is essential to the future of the scientific enterprise. All of you are here because you had good science training, or you're a reaction against bad science training. But you had to go to school and learn about science in high school. And it's not only important for the new scientists that our middle school and high school science education captures and inspires and equips to go on and become great scientists. Our whole society, everybody in the society lives in a very technologically, rapidly advancing world where science is increasingly important. Everybody can vote. Everybody can have a say in what kinds of scientific decisions we make. And so having a healthy scientific middle and high school science education system is an essential part of the whole scientific enterprise ecosystem functioning well. And that's what I'm going to talk about today. But I want to start with a story that you'll see the relevance at the end of the talk. So before I moved to California 2 years ago, I spent 30 years in Washington, D.C. I was just out of graduate school and starting my first job in 1982 when we had what I would say is the worst day for Washington, D.C. Up until 9/11 happened. It was a stormy day, snow, ice. There was an accident on the metro system that killed several people, and a plane took off from National Airport and slammed into the 14th Street Bridge. And looking around the room, many of you were not alive yet. But it was a terrifying thing. Several people were killed on the bridge. The plane slammed into the water. Many people on the plane were still alive. And so they were trying to get the people out of the plane and into the water, which was, of course, freezing cold, big blocks of ice floating around in it. And they brought in helicopters. Of course, the traffic was completely backed up because of the accident on the bridge. They brought in helicopters to try to pull people out of the water. And it was very clear that people were dying because they couldn't be gotten to quickly enough. So there's this poignant footage of a turned out to be a flight attendant who was reaching up to try to grab the life ring to be pulled out of the water, and she was too cold to hang on to it. She kept slipping off. And this man who had been stopped in traffic jumped off the side of the Potomac, swam into the river, and pulled her to safety. A hero, right in our midst, a hero. His name is Lenny Skutnik. Two interesting things about Lenny Skutnik. This is total inside the beltway kind of stuff that those of us who live in Washington love. This happened in January, right before the State of the Union address. A couple weeks later, Reagan had Lenny Skutnik sitting next to Nancy Reagan in the presidential box at the State of the Union address. It was the first time that a president had somebody up there sitting next to the First Lady who he could point to and say, I want to talk about this person. It was Lenny Skutnik. So that's one fun fact about it. The second fun fact is that now happens almost every State of the Union address. The president has somebody sitting up there who he, maybe someday she, can point to and say, this is this person who's done this great thing. And in Washington, those people are called Skutniks. I love that story. It's so inside the beltway. Okay, remember that story. We'll come back to it later. As Justin said, I got my start in science working with formalin-fixed paraffin-embedded tissue and trying to do molecular biology on those samples, eventually leading to trying to figure out the genetic sequence of the 1918 pandemic influenza virus. This is a picture from those days. You can tell it was a really long time ago because my hair was brown, and that is an autoradiogram, which I'm sure none of you have ever had to do. It is not the best way to do sequencing. It took us 7 years to determine the entire sequence of the virus. You could now do it on your coffee break. I call that progress. I'm going to skip over a couple of jobs and get right to the National Center for Science Education. Some of you in this room, if you came here because of the Skeptic Society announcement, would know this lady on the right, Jeannie Scott. She was the founding executive director of the National Center for Science Education, which has been, as our tagline says, defending the integrity of science education for over 30 years. Generally, that has meant making sure that science is taught in science class and not non-science. So evolution is taught in science class, not creationism, not intelligent design. Climate science is taught in science class, not debate over whether the climate is changing, not debate over the science. There was a case in Dover, Pennsylvania. The decision came down 10 years ago that ruled that intelligent design, which was the evolved, if you'll excuse the pun, the next evolution of creationism, was also declared to be not science, to be religious in nature, and unconstitutional to teach in public schools. So game over, right? It's unconstitutional. We no longer have a problem with teaching creationism in public schools. I'm going to tell you that that's not the case. Just another little story about this picture. I had been at NCSE for about 2 weeks when Bill Nye called us and said, I'm going to debate the founder of the Creation Museum in Kentucky. Can you help me? And we said, sure, we can help you. Don't do it. He said, no, I'm going to be awesome. This is going to be different from all those other debates. And we said, well, if you insist, at least come up and let us help you prepare. So he came up, spent a whole day with us. As far as my children are concerned, I have never done anything in my life as important as that. It's meeting Bill Nye. I'm like, now you're really something, Mom. The lower thing, 5 years ago, we added climate change to our mission because we were starting to see climate change turn up in the same kinds of contexts that we see creationism turn up, where every year about 10 or 12 states pass a piece of legislation that says teachers should be allowed to teach both sides, or teach the controversy, or teach the strengths and weaknesses of various scientific theories. Evolution used to be the main one that was in that list. About 10 years ago, we started seeing climate change show up as another area of science that the teacher should be allowed to teach whatever they wanted on. Part of our work is making sure that those bills don't pass. So we've gotten involved in climate change education. We just published the first major national survey of middle and high school science teachers to find out what are they teaching about climate change, because no one knew. So that came out in Science in February. I'll talk a little bit about the results. Okay, let's talk about scientific literacy in the United States if you want to start out depressed and become more so. So the first one here, that antibiotics kill viruses as well as bacteria. There is very little understanding about this in the general public, and it's not much better among entering college students. The UA Gen Ed is a group of students who have taken a science for non-majors course. You see it made not a whole lot of difference on that point. More terrifying, perhaps, is that, what is it, some 55% of the population does not know that the Earth takes 1 year to go around the sun. I'm just saying. That's not good. Okay, I just as a little follow-up on the antibiotics one, because I know that this is one that you guys care about. Among students who had taken more than 4 science classes, that number only went up to 75%. So I don't have that on the graph, but that's just a note that seems to be a tough concept for people to grasp. Okay, but there are some areas of science where there's a really enormous disconnect between the scientific community and the general public. All of these data come from a survey that was done between Pew and the American Association for the Advancement of Science, where they asked a series of questions of the general public and then of people who subscribe to the journal Science. That was their proxy for scientists. I think it's a pretty good proxy because it costs like $600 a year. So you're really not going to subscribe to it unless you're pretty involved in science. But you can see there's a big disparity on a series of topics. In evolution, almost every single scientist knows that humans have evolved over time, but some 40% of the public don't agree with that. This is all scientists. Well over 80% agree that climate is changing and humans are largely responsible. If you were to ask specifically climate scientists, that number climbs to almost 100%. But only about 50% of the general population accept that. The biggest disparity, interestingly, was whether it's safe to eat genetically modified organisms, that almost all scientists say, yes, it's safe, whereas a very low percentage of the public do. This cursor is really rambunctious. And then vaccines. It's not as big a disparity, but it's still there. Almost all scientists say vaccines should be required. A smaller number of the general public agree with that. So what's going on with that? These are settled areas of science. There is not a substantial debate over any of those issues in the scientific community. The evidence is overwhelming. Why don't people agree with the scientists on this? Well, let's explore some hypotheses. Maybe people hate science. You know, you do run into a lot of people who say, oh, I hated science in school, it's so boring. But when they asked these people whether science has made life better for people, most of them said yes. Indeed, most of them said it's worth investing money in basic science research. And considering how many people would like the federal government to go away, that's a nice big number to say, yes, this is worth our society spending money on. Maybe they think scientists are incompetent. Maybe they don't think scientists are knowing what they're talking about, and maybe I know better than the scientists do. But this is a very interesting study by a behavioral psychologist at Princeton named Susan Fiske. And she asked people to evaluate different careers based on how competent do you think these people are in this career and how warm do you think they are. So look at scientists, they're way over here. We're like super competent. We're almost the most competent. That's really good, right? So people think science makes their lives better. They think research is worth investing in. They think scientists are super competent. So what's the problem? Why don't they agree with us? Well, let's take a look at this other axis over here of warmth. Warmth is a measure in this study. Warmth was a very good correlate with whether you trusted people or not. Whether you trusted people in a certain profession was based on how warm they were. So you can see that on this scale, scientists don't come out so well. We're sort of there with, oh, maybe, the DMV clerk, not quite as warm as a bus driver, maybe a little warmer than a police officer. That's not great. So they think we're smart, but they don't necessarily trust us, is the bottom line there. Here's another problem. Most Americans don't know any scientists. This is a poll done by a group called Research America that advocates for more biomedical funding or research funding. And they do this every year. They call people up, and one of the questions they ask is, hey, can you name a living scientist? 30% of Americans can name a living scientist. And some of them name Mehmet Oz. Again, I'm just saying. If you've never met a scientist, if you can't name a scientist, if science is something so foreign to your life that you can't think of a single one, that's a problem for us in terms of being trusted. So what is going on? It turns out it's not actually about the science. On these issues, people identify with the people around them. And if their communities feel a certain way about a particular area of science, they're much more likely to agree with the people in their community, the people they know and trust, than with scientists who are this big unknown. So they don't trust or identify with scientists necessarily. And critically, some areas of science come right into conflict with their core values. So let's talk a little bit more deeply about evolution. This is Gallup has been asking the question for over 30 years, whether God created humans in their present form in the last 10,000 years. That's the top line. Whether humans evolved, but God guided the process. That's the dark green line. And then humans evolved, but God had no part in the process. That's the light green line below. And you can see that these numbers don't budge. They're incredibly consistent over time. That about 40% of Americans believe that humans were created in their present form in the last 10,000 years. I will say that when they did the poll this year, the numbers among young people are starting to change a little bit. Our society is becoming less religious over time, and it does seem to be affecting this number. But you can see it's basically been steady. So why? Why is it so important for creationists to reject evolution? Why is it so important for these people to say, no, humans did not evolve. Humans were created by God specially. And these were the kinds of answers that they gave on another poll that looked at, asked religious people why they had the beliefs that they have about evolution. The organization is called BioLogos that did this poll. Does a lot of very interesting work in the area of science and religion. So you can see the kinds of things they say, that God says so, that the Bible says so. This is a foundational aspect of my faith that humans are special, that not believing this will have personal consequences for me, that it will have bad consequences for society if we believe that humans are just like other animals. And then you can see this sample answer, which is very, this is the answer that you get from a great many people. This was one person saying this, but that you get some variation on this from a lot of people, that if you believe in evolution, that means you're saying Genesis is not literally correct, and then your whole faith crumbles. So you can understand if someone is a person of deep faith, and they feel that accepting evolution means that their faith falls apart and you say, you pick evolution or your faith, they're going to pick their faith. So going back to this idea of you form your opinions of scientific areas based on your community, not upon the evidence, that these bullet points play into that people who are very committed creationists, who are very sure that they're correct, because they also asked people, how sure are you about this? And these are the people, 29% of the creationists who are 100% sure that they're right. They live in communities where everybody agrees with them. They feel that if they change their mind, it would cause real disagreements with their family members and their community members. They very often belong to churches that have explicitly said, you cannot accept evolution and be a Christian. They have often gone to schools where they were never taught anything about evolution. And I think this last one is the one that's most sobering for what I'm talking about, that 85% of them who had learned about evolution in school, it didn't change their minds. So you're up against a situation where the scientific evidence doesn't matter. Okay, let's switch gears a little bit and talk about climate change. Here you have a situation where it's not a religious rejection of the science. It's based on ideology, but again, with community identification. So you can see that if you ask people what is causing climate change, about half the general population says human activities are causing climate change. But Republicans are at about half that rate, and Democrats are about 50% more than that rate. Whereas if you ask whether climate change is happening, about half of people who self-identify as Republicans will say, no, it's not happening. So this is an identification with a different group. It's not your religious community, it's your political community. So that's okay. Democrats and Republicans are spread out across the country, right? So you shouldn't necessarily be in a community that all thinks the same way as you do about climate change. But in fact, that's not so true. I find that this is a really deep set of data, and we could talk about it all day. I just want to highlight one point. So this shows the United States by county, and the counties are colored according to whether the presidential election results were close or not. And by close, they meant within 20 points, so not particularly close. If it was a greater than 20-point spread, they called it a landslide. So you can see in 1976, in the presidential election between Ford and Carter, there's a lot of white counties, which they label competitive, where the spread was less than 20%. When you go to 2004, this is Bush versus Kerry, there are very few white counties left. Almost all the counties were either a landslide for the Republicans or for the Democrats. And this is not by congressional district where gerrymandering could affect it. This is just by county. So this is suggestive that the book by the journalist was called The Big Sort. And he argues that people are sorting themselves into affinity communities. So you actually are more likely to be in a community where either everybody accepts climate change or everybody rejects climate change. Everybody's a Democrat or everybody's a Republican. So you don't have that exchange of ideas. This is also affected by where people get their news. That has also become much more segregated over time. Used to be there were just the big networks and everybody watched that news. Now you can choose where you get your news. And you can see that people who self-report as consistently liberal get their news from completely different sources than people who report themselves as consistently conservative. So again, you have a situation where instead of hearing a diversity of views and feeling like it's okay for me to accept this area of science because some people in my community do, you're in a situation where nobody in my community does. And it raises the barriers to being open to hearing the evidence. Okay, so finally, we get to science education. What is the effect of this in the science classroom? So these two bars represent the results of two different surveys. The upper one was done in the it was 2008, and it asked teachers what the teaching practices are around evolution. The 13% in the red bar are teachers who self-reported that they teach creationism. This is U.S. public high school biology teachers reporting that what they teach is creationism. This is against the law, this is unconstitutional, this shouldn't be happening. But not only is it happening, but they're willing to say so on a survey, which I find sort of astonishing. That affects about 450,000 students a year. What they're learning in biology class is creationism. Only 28% that we have there in the green bar are teaching evolution according to what the scientific standards recommend. 28%. Then you have this big group in the middle. Almost 60% of US high school biology teachers report that they don't teach evolution straight up. That's the best way I can generalize about that group, because there's a lot of different things going on in there. Some of them just skip evolution. They just don't talk about it. Some of them present it as one valid scientific theory among several. Some of them teach it as a debate. Some of them say, I don't express a position, I let the students decide. Which may sound open-minded, but can you imagine if a teacher were saying that about the periodic table, or plate tectonics, or F equals MA? They wouldn't say, I don't know, I don't have an opinion on F equals MA, I let the students decide about that. So there's something special about evolution there. 60% hedge in some way. As I mentioned, we just finished this National Survey of Climate Change Practices, and these are the numbers from that survey. It's better. About 50% are teaching what the preponderance of the scientific evidence shows, which is the climate is changing and humans are responsible. They're teaching about the greenhouse gas effect. They're teaching about sea level rise. They're teaching about the things that we hope are the next generation who are going to be faced with this and have to make decisions about it and need to be learning. About 10% are flat out teaching that climate isn't changing or that humans are not responsible. Because we surveyed all middle school science teachers and biology, physics, chemistry, and earth science high school teachers, that is an enormous number of students represented there in that 10%. And then we have this group of 36% who are somehow, again, presenting this as this area of science is not like other areas of science. This is an area of science that's, whoop, whoop, danger, Will Robinson. It's not quite like everything else. It may be debatable, which gives kids a really mixed message about how science works. So think about what kind of environment these teachers are in. They're teaching in communities where acceptance or rejection of established science tracks with the community values, not with the scientific evidence. And in many communities, the rejection of these established areas of evolution and climate science, the rejection of them is very widespread or even the norm. That's the environment these teachers are in. So here they are in their classroom. They know most of them know they should be teaching the science, but they're in a community where they know that there is a lot of pressure not to talk about those things or to teach a debate. So what teachers tell us is many of them report that they're not very confident of their mastery of the science in these areas. As I said, a lot of teachers in many parts of the country really didn't get a strong basis in evolutionary science. Again, this is a process that continues through time. If a community has always had doubts about evolution and people grow up in that community and go to college there and teach there, they may not have gotten good training in it. And climate science is just new. Anybody who's been teaching for more than 10 years almost certainly had no formal training in climate science when they were going to school. So there's the topical expertise that's missing. And if you're going to teach something and you think people might make a fuss about it, you want to really have your ducks in a row, right? You want to really know that you've got the science down pat and you'll be able to deal with any kind of pushback. A lot of teachers don't have that. And almost none of them have ever gotten any kind of specialized training in how to deal with it if you do get that kind of pushback. What should you do if a parent comes in and says, I don't want you teaching my kid evolution, I want him to be able to opt out of that class? Or how can you be teaching climate science like it's a settled science when it's still up for debate? You're just indoctrinating my kids with liberal political views. And I know this happens because these people call us. And what the National Center for Science Education does is talks them through how can you resolve this issue. And it's something that when you've gotten some training and, very importantly, you know that somebody's got your back, it's much easier to teach these topics and you go into them with much more confidence. But given the environment that a lot of teachers are in, I think it's not that surprising that we have that many teachers in that yellow zone. So just to sort of dot the I's and cross the T's, the problem is not so much that the science teachers themselves don't get it. We know that some of the science teachers do reject the established scientists. Those were the red bar teachers. But in general, teachers are closer to the scientists in their views of these areas than they are to the general public. So you can see that when it comes to evolution, high school biology teachers, some 75% of them either accept that humans evolved over time without any involvement by God, or that humans evolved over time and God was involved, which is sort of a theistic evolution that is fine. They're teaching, the science of evolution, and that's not a problem. Only 16% of the high school biology teachers are creationists, and that's reflected in that red bar. When it comes to climate change, very similar, that 67% of high school, middle and high school science teachers accept that human activities are changing the climate, compared to about half of the general public. So it's not so much that the science teachers themselves are rejecting the science, and so I think this idea that they're really being affected by their community environment is a pretty strong hypothesis. So I think we go back and look at this bar and we re-diagnose the problem. There's a very strong tendency in the scientific community to look at these numbers and say, those science teachers are really screwing up. They need to step up their game. They need to do the right thing. And I hope that what I've told you is that that's not particularly fair. Of course, we want all the science teachers to teach these topics straightforwardly, just like they teach all other areas of settled science. But maybe we need to have a little empathy, and we need to recognize that we need to provide some more support so that they can teach these topics confidently when they are really concerned about their community's reaction. So what the National Center for Science Education is doing about it is, first of all, this national survey program. We can't do anything about it if we don't know what's going on. So we are going to try to do regular surveys to find out what is going on in the classroom. This will allow us to report whether the other things that we're doing are having any effect. Very important control. We also have started a network directly to support teachers. It's called NCSE Teach. It's available to anybody who teaches evolution and climate change. And the attitude is, we get it. These topics are particularly challenging, and we can help you with it. We can help point you towards really good resources. We can help point you towards professional development so that you can become more confident in your content expertise. And we can show you how to deal with people who come in and give you grief about teaching it. We have 4,300 teachers in that network now. What they tell us is what they want more than anything else is to have a scientist come to their classroom around these topics so that they have somebody who really knows the science helping them teach these topics. We've piloted this program in 30 classrooms in the fall. We have 100 classrooms this spring. This is mostly graduate students who go out and work with the teacher for the whole semester. They actually go to the classroom twice, but they're in contact with the teacher and the students for the whole semester. The teachers really appreciate that. The other thing, though, is in addition to supporting the teachers directly, we think it's important to support the teachers indirectly. So we've started something we're calling Science Booster Clubs, where members of the community who care about their kids' STEM education, which is a lot of people, can gather together and raise money for their local science teachers, organize fun, hands-on science events to normalize science in the community, to get scientists out into the community. So we're going to start solving that problem of most Americans can't name a scientist, have never met a scientist. We want to have a way for teachers to know that they do have a community that supports them and really cares about the science being taught well. We started this last April. It was a complete shot in the dark. We had no idea whether this would work. And my expectations were completely blown out of the water. In less than a year, we have 4 booster clubs in and around Iowa City. with over 500 members. They've held events that have provided informal science outreach education to over 5,000 people. This summer, that's going to skyrocket because we have a booth at the Iowa State Fair. So we're going to see tens of thousands of people. And these are hands-on experiments that people can do to actually experience evolutionary science, experience climate science. They can go into a greenhouse and measure the CO2 levels with nobody in there and with 20 people in there. They can blow into water and have it change color as it becomes more acidic to learn about ocean acidification. It's very participatory. The raising money part has not been as successful, but local businesses are now starting to see that this is a great way for them to support science in their communities. These grants, teacher grants, they can't ask for more than $250, and it would break your heart what these teachers ask for. That one of them asked for $200 so she could buy some more safety glasses for her lab. She only had enough for a third of the students. So they had to share them in order to be able to do a lab. And this was not in a poor inner city school. This was in a suburban school where you would think the science lab would be decently equipped. So that's impacting a lot of students with better science equipment. And it has pulled in lots and lots of volunteers, in this case from the University of Iowa, but from science communities around the country could get involved in this kind of program. We're actually set this up as a research project. So we're doing before and after surveys of attitudes towards science in the community and looking at the experience of the teachers in those communities to see if this makes a difference. We're hoping to take it national next year. So I hope when we do that, someone in this room will say, I want to do that in Houston. We're supported by our members. We have about 5,000 members. We would love to have you join us because that's the only way we can do this. And it's a huge, diffuse, long-term problem. And I've got to tell you that foundations and funding agencies are not really excited about funding projects that are aiming to improve public schools. You say that and they go, well, that's impossible. There's no amount of money you could spend and fix that. We think that if you work strategically, you really can change it. We think we can make a real difference for teachers. So we're very small. This is it. This is NCSE. We are mostly in Oakland, California, but we have someone in Boston and someone, as I said, in Iowa. And I really appreciate you sitting through this lecture. And so I have a reward. Because who doesn't need some cute in their life? Did that go sideways? How did that happen? What do I do? Can I turn it around? Turn your heads. This is my puppy, Buster. He really, really loves peanut butter. So that was his prize. That was his reward when he did something really, really good. And boy, he loved it. So that's it. That's all I got. Happy to take questions.